Alright guys, there's a chance I'm not going to be in school on Monday, so I'm making this video from home. It's a little bit more awkward than normal, but it's going to work. So on Friday we started our chapter. We're learning about congruent triangles. We learned that if we can prove that all 6 parts of 2 different triangles are congruent, then those triangles are congruent. So there's 3 angles, 3 sides. If we prove that all 6 parts are congruent, remember corresponding parts are congruent, then we can say that the 2 triangles are congruent. Today, we are going to learn that while the definition of congruent triangle states that all 6 parts of a congruent triangle, congruent corresponding parts, would be congruent to the other triangle, you really only need certain pairs of congruent corresponding parts. So in this case, you only need 3 to be able to prove that the 3 sides are congruent. If we can prove that all 3 sides are congruent, now we can say that the triangles are congruent. Once we say the triangles are congruent, now we can say that all the angles and all the sides are congruent, because by definition, if we stated the triangles are congruent, then that means all the parts of the triangle are congruent. So if we're looking at this first statement, side AC is congruent to side XY. We know when they mark them with the same number of dashes, those segments are congruent. We know that side CB is congruent to side YZ. And notice the order. I went from the angle in between these 2 sides down through the one marked 2 hashes to B. I got to go in the same order here. So the angle in between the 2 dashes, 2 different number dashes, down towards Z. So CB is corresponding to YZ, and they're marked congruent. Side BA is marked congruent to side ZX. Notice the order I did it in. We can't say BA is congruent to XZ. The corresponding parts have to be in order when you name them. So now, because we learned this shortcut postulate, side congruence, now we can say that the 2 triangles are congruent. So if I say triangle CAB is congruent to this other triangle, remember I got to go in the right order. So that means CA is congruent to YX, right? So this triangle is named with YX first, and then the last angle. So CAB, 1 dash to 3 dashes, back up to 2 dashes. 1 dash to 3 dashes, back up to 2 dashes. We can say these triangles are congruent. And now we know that not only are the 3 sides congruent, that the corresponding angles are also congruent. So angle C is congruent to angle Y, angle A is congruent to angle X, and angle B is congruent to angle Z. The other shortcut we're going to learn is what if we only know 2 sides and 1 angle. Now it's got to be specific angle here, and it's got to be an included angle. Well, what does that mean? An included angle is an angle formed by 2 sides lying directly between them. So angle W is the included angle between this side and this side. This segment XW and segment YW, where they meet, forms that angle. So that makes W the included angle there. If I'm looking at these 2 sides, this side and this side, W is the included angle between these 2 sides. Angle Y is not included. It's only part of on one segment. Angle X is not included. So when we're talking about the side angle side congruence here, it's 2 sides, but the angle has to be in between them. So if we're looking at this pair of triangles, we have a side congruent to a side. We have another side marked congruent to another side. And we have the angle that's in between those 2 sides. The included angle is also marked as congruent. So if we know that 2 sides and 1 angle, and that angle is included, we can say that these two triangles are congruent. So side MN is congruent to side PR, angle N is congruent to angle R, and this is the included angle. These are the included angles. Side NL is congruent to side RQ, and now we can say that these two triangles are congruent. So triangle LMN is congruent to triangle QPR. This side is a corresponding part to this side. Even though it's not marked congruent in here, now that we know the triangles are congruent, we can say that those sides are congruent as well. And we only have one angle, pair of corresponding angles marked congruent, but now that we know the triangles are congruent, we can say that angle L is congruent to angle Q. Angle M is congruent to angle P. Another shortcut, so this one had two sides and included angle. This one, still only three things to prove congruent, but now it's two angles and an included side. So the side is in the middle of the two angles. The side is in the middle of the two angles. So in this case, if we've got angle Y and angle X, the side that is connecting those two angles is the included side. So side YX is the included side between angle X and angle Y. Side XZ is not in between angle X and angle Y. So that's what we're talking about when we talk about included side, the side directly between the two angles. Remember, I'm doing this without a class, so you guys can pause this anytime you need to catch up. All right, so angle side, angle congruence. We can say ASA, noting that the side is in between. So here, we can say that angle Y is congruent to angle L. They're both marked with that little square that tells us they're right angles, which tells us they both have the same measure, 90 degrees, which means those angles are congruent. We have side YZ is congruent to side LN. And we have the other angle that includes these sides. Angle Z is congruent to angle N. So we can see here the side that is marked congruent is the side that connects the two angles that we know are congruent. So now we can say that our two triangles are congruent. Triangle XYZ should be congruent to triangle MLN. Now that we've stated the two triangles are congruent, we know that all parts are congruent, even if they're not marked up here. Our next shortcut, angle, angle, side congruence. So here it was two angles with an included side. Now it's going to be two angles, but the side is not congruent. I'm sorry, is not included. So it's a non-included side. So we're still proving triangles are congruent with this shortcut, this postulate, but they're two different postulates, so you have to know the difference between them. So angle, side, angle, so two hashes tells me these two angles are congruent. One hash tells me that these two angles are congruent. One dash tells me these two sides, corresponding sides of these two different triangles are congruent. We should be able to see, so the included side would be here or here, right? So two angles, but it's a non-included side. It's not in between the two angles. It's at the end, right? It's it's in that order. Angle, angle, side. Okay? So angle P is congruent to angle V. So angle R is congruent to angle T. Side QR, segment QR is congruent to segment ST. So these are two angles and a non-included side of one triangle congruent to the corresponding two angles, a non-included side of another triangle. Now we can state that triangle PQR is congruent to triangle VST. PQR, two dashes, no mark, 1 dash. 2 dashes, no mark, 1 dash. So order is important. It's got to be corresponding parts. So once we know the triangles are congruent, now we know that all the parts, all the sides, all the angles are congruent. All right, so we've talked about postulates and shortcuts that allow us to prove that triangles are congruent. Kids sometimes want to say that there's a postulate of congruence called AAA, or angle, angle, angle. But angle, angle, angle is not a postulate that proves triangles congruent. And why is that? Well, that's because if you've ever used one of these little tools on a computer where you can drag the dimensions of the image a little bit bigger. So these two triangles we can see are exactly the same size, right? So that means all three angles are congruent and all three sides are congruent. But using one of these little corner drag tools, I can create a much bigger triangle that is proportional to the other. It's proportional to this smaller triangle. The side measures are all longer on this one, but the angle measures are the same. They're proportional. We did not change the angle, the size of any of the angles. So we can't say just because the angles are congruent that the triangles are congruent. Could they be? Certainly they could be, but they do not have to be. So this here is kind of another way of showing these two triangles. This angle and this angle are congruent. This angle and this angle are congruent. Remember, the third angle theorem tells us these two angles are congruent, but the sides are not the same length. So AAA, angle, 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 does not prove that triangles are congruent. The other one, sometimes kids want to use, they think it's a safe way to use a curse word in here. If you spell this backwards, it's a curse word, right? We're not going to spell it backwards, but side, side, and a non-included angle does not guarantee triangle congruence. And I'm being funny here because if you flip the order, it would be a curse word, right? Side, side, angle does not prove that triangles are congruent. You have to remember which postulates, which set of three different corresponding parts will prove will prove that angles or triangles are congruent, right? So we learned that side, 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 all three sides are congruent. Yes, the triangles are congruent. Two sides and an included angle, so the angle in between them. If those three corresponding parts are congruent in each triangle, then the triangles are congruent. Two angles with an included side, so angle, side, angle. If the corresponding angle, side, and angle in both triangles are congruent, then their triangles are congruent. And finally, angle, angle, side. So two angles and their non-included side. So some postulates, and not really postulates, but rules that kids think are postulates. Side, side, angle, and angle, angle, angle. Triangles do not necessarily have to be congruent if these corresponding parts are congruent. Could they be? Yes, but we cannot state definitively that they are congruent with just these corresponding parts congruent. Okay, don't forget to submit your notes. Your assignment is a worksheet in Alex, and I think it's AWS A 4-2 and 4-3. And then tomorrow we'll do AWS B 4-2 and 4-3. All right, I will see you soon.